Students, today we are going to discuss the topic force of attraction between two long parallel wires. For that, we consider the two wires. Suppose this one is a wire 1 and this one is a wire 2. Both these wires are at a distance d apart from each other. Let the current through the first wire is I1 and the current through the second wire is I2. Both the wires are at a distance d. The magnetic induction produced by the first wire is B1 is equal to mu 0 I1 upon 2 pi d and B2 is equal to mu 0 I2 upon 2 pi d. These are the magnetic field of induction produced by the first and second wire respectively. This magnetic field of induction is on the wires act on the wire second by the wire first, and this is the magnetic field of induction produced by the wire second and act on the wire first. Now we determine the force by the Lorentz law. That force is equal to, simply we say that force is equal to I B into L. In a simpler form, we remember it as force is equal to I L into B. Now we determine first of all the force on the wire second. The force on the wire second by the wire first will be F is equal to current on the second wire will be I2. Magnetic induction by the first wire on the wire second will be equal to mu 0 I1 upon 2 pi into d. Let's consider the smaller part of this wire is dl, and that dl is the length of the small element. Now integrating this equation, we get the total length of this wire is dl. Call this equation number 1. Now this is the force of attraction between the two wires, by the wire on the wire second. Now we say that the force per unit length will be F dash will be equal to F upon L will be equal to mu 0 upon 2 pi I1 I2 upon d, where this is the force per unit length on the wire. Let's consider the wire of second wire is of length L. This force will be equal to F is equal to I will be the current flowing through this, that will be I2. Magnetic field of induction is B and it is of length L. Then we say that this equation is I2, B is mu 0 I1 upon 2 pi into small l. From this equation we say that force per unit length, we rearrange this equation, force per unit length will be equal to I2 by rearranging mu 0 I1 I2 upon 2 pi into d. This is the equation for this. Now similarly we determine the force on the wire first by the wire second. That force we represent by the wire first by the wire second will be F21, which is exactly equal in magnitude but oppositely in direction. Therefore we say that F12 is exactly equal and opposite to the force F21. Hence we say that the force per unit length will be equal to mu 0 I1 I2 upon 2 pi d. This is about the force of attraction. Now from this we discuss the definition of 1 ampere. Definition of 1 ampere. The definition